In this video, we introduce our paper Blending-NeRF, text-driven localized editing in neural radiance fields. Blending-NeRF is an innovative localized 3D editing method that enables users to perform natural modifications to a source object by text prompts. Blending-NeRF offers various modification options with explicitly predefined three types of editing operations: color changes, density addition, and density removal. We aim at text-driven localized 3D object editing. There exist previous studies on localized object editing. For example, Edit-NeRF or NeRF editing require user scribble or 3D modeling tools to perform localized editing. However, these methods only offer limited and non-versatile editing options, partly because they do not use text as input. Text-driven editing methods also exist, such as Clip-NeRF. It presents category-level and fine-tuning-based editing approaches. However, the category-level approach requires a large volume of training data for the targeted category, and the fine-tuning-based approach fails to edit the density of NeRF. We propose the novel Blending-NeRF architecture that combines a pre-trained NeRF with an editable NeRF. The pre-trained NeRF captures the original 3D model information and provides the information to the editable NeRF. The editable NeRF performs editing to the specific regions of the 3D scene using the original information and language guidance. Here we freeze the pre-trained NeRF and train only the editable NeRF with randomly initialized weights. The editable NeRF extends NeRF to produce two blending ratios in addition to a density and a color. We design that each blending ratio determines how much the original 3D information is not used. It enables our approach to perform the predefined editing operations to desired regions of a scene. Blending-NeRF renders three types of images using proposed blending operations and volume rendering: original, editable, and blended images. Using these three types of images, Blending-NeRF edits the original object to match the meaning of a given target text under the guidance of the text-driven objective. However, using only the text-driven objective is not sufficient for localized editing, as it does not serve to specify the target region. Thus, during training, we specify the editing region in the original rendered scene using the source text. Simultaneously, the editable NeRF is trained to edit the target region under the guidance of the localized editing objective. Now we show the localized object editing results using Blending-NeRF. We first performed experiments on editing different synthetic objects with various editing operations, such as addition or removal of densities and color changes. Our approach clearly achieves a detailed editing of the target object while preserving the source structure. For example, when given a source text, boat, and a target text, massively exploding boat with a lot of smoke and blue flame, the appropriate ambient effect appeared naturally along with stylizing the target object. We further focus on experiments that edit the boat object with various target texts. These results show that Blending-NeRF naturally and locally edits the target object that matches the target text. For example, we can naturally make the boat shipwrecked or get into a black hole. Here is an example of a training process when given a source text, boat, and a target text, exploding boat, dynamic, realistic. Note that we use Instant NGP as a backbone for this example. Blending-NeRF quickly performed editing that fits the target text well. Now we show examples of localized object editing on real-world scenes. We can edit the source objects such as pinecone and flower, using Blending-NeRF for various target texts. For example, we naturally turned a pinecone into a pineapple or burned it vividly. Also, we can edit the flower into the beautiful Swarovski blue crystal flower or put some snow onto the flowers. Moreover, we are able to remove the pinecone or flower entirely from the scenes using the density removal operation. Thank you for watching this video.